Hi guys, back with another video. So on this one we'll take a look on how to overclock your 8th generation Coffee Lake CPU like the 8700K or the 8086K, so the 40th anniversary edition of the Coffee Lake 6 core, or any other CPU from the 8th generation CPU lineup on the EVGA Z390 DARK. So of course the correct chipset for the 8th generation CPUs would be the Z370, but they all work just the same on the Z390 boards. So on this one we will be using the EVGA Z390 DARK, of course. So let's take a look on how these overclock and what you should be doing if you want to run these CPUs on this particular motherboard. Now I do have my CPU delidded already, so that means I have much better temperatures than I would have if I had the CPU just like stock, so not delidded. Delidding can generally give you like 100 to 200 extra megahertz. So if you have a really good CPU already without delidding, so you are doing like 5.3 or even close to 5.4 in Cinebench, then you definitely should consider delidding your CPU. If you have a really bad CPU, so you have an 8700K or 86K that can't even do like 5 GHz, or it's barely doing 5 GHz, even with like 1.3 volts, then you generally may not even want to try delidding, because delidding a bad CPU will not make it like a great CPU. So generally I would risk the whole CPU only if it's a really good one, because you can always, it's easier to resell a CPU like in the second-hand market if it's not delidded, because it will still have like warranty and so on. But yeah, so let's get going. Let's see how this runs, and let's see what settings you should use if you want to run these CPUs on the Z390 DARK. So let's press yes to enter the setup. So we will select advanced configuration, so enter setup, and this is what we will see when we just land on the BIOS. So we can see Intel Core i7 86K CPU at 4 GHz. The CPU die temperature only at 32 Celsius because it's delidded. So the easiest way to get going is to press left arrow on your keyboard, go to the extras, then down arrow, and go down to the OC profiles and select my 4300 MHz 17, 18, 18, 5.2 GHz daily profile. The overall system I'm using is exactly the same as always. So EVGA Z390 DARK, then the Intel 86K with original Intel IHS. So I'm just using the stock Intel IHS with liquid metal between the die and the IHS, because the CPU's PCB thickness is quite thin on these 8th generation CPUs. I cannot use direct die cooling solution. So I have to use the Intel IHS or any other IHS. So I'm just using the stock one that came with the CPU, and I'm using liquid metal to get the best possible thermal performance. And then just KPX on top of the CPU IHS. So, and then the memory is 2 sticks of Kingston HyperX Predator 4133 Cas19. So those are A2 PCB Samsung Hdi based DDR4 memories. Then very simple VGA, and then Superflower 8-pack 2000 watt power supply. So very simple setup, same as always, same as on my other videos about this board as well. So you can start with my profile just like this if you have your CPU delidded. If you don't have your CPU delidded and you are not sure about your cooling solution, then I would start with a frequency of like 4.8 up to 5 GHz. You can use same like cache, because 45 is nearly the stock value, so it will do that, I'm pretty sure. And so if you don't have your CPU delidded, I would recommend you start with a Vcore value of 1.15 to 1.2 volts, just to be safe and sure. And then you can ramp up once you are once you have tested the low value and you know that you have a lot of headroom left. But if you have your CPU delidded and you are sure about your cooling solution, then you can start with like 1.3 volts. So just saying. So because I already know my cooling solution, I will start with a frequency of 5.2 gigahertz. Cache maybe 47 to 48. Cache is not that important on the mainstream CPUs, so it's like the number 3. So it's like third important thing about the overall rig when it comes to the performance. So first one is the actual CPU core, so the core frequency. Then the second important one is the memory, and third one is the cache. On the X299, Skylake X or Cascade Lake X CPUs, there the so-called mesh is a lot more important for performance than the cache of these mainstream CPUs. So on X299 large CPUs, you have to really max out the cache or the mesh to get the best possible performance. But on the mainstream CPUs, it's not that important, so it doesn't really matter if your cache is at like 4.7 or 4.8 or even like 51. It doesn't really matter. It doesn't have that much. It doesn't have that much impact on overall performance. So often I don't even try to max it out fully. So just set it at something that's high enough, but it doesn't have to be like ultimately maxed out. So I will use it at like 4.8. AVX ratio offset is very, very handy. So if you find out that you can do like 5.3 gigahertz fully stable in non-AVX situations, so let's say that Cinebench R15 is completely easy, then you can even run few hours of Prime 95 non-AVX workload, so you can confirm that 5.3 is fully stable in non-AVX situations. You can use the AVX ratio offset of 2, and then it will drop the core frequency down to 5.1 in any situations where AVX instruction sets are being used. So a good value generally here is 2 or 3. So because the AVX instruction sets, they really hammer the CPU a lot more, so you cannot remain stable in AVX based workloads if you were stable in just like normal non-AVX situations. So that is why when I start testing out CPUs, I always use Cinebench R15. It's a very easy way to determine like how good your CPU is. If you cannot pass 5.1 gigahertz even at 1.35 volts, it already tells you that the CPU is not very good. But let's say if I have CPU deleted, I can easily pass 5.4 gigahertz Cinebench R15 at 1.35 volts. It already tells me that I have a relatively good CPU. So then I could aim for like 5.3 gigahertz non-AVX stability for daily use. So I could try to run a few hours of non-AVX Prime 95 at 5.3, 1.35 volts. If it's stable, then I could just use AVX ratio offset of 2 or 3, and that would pretty much be fully daily stable, because then it would drop the CPU frequency to 5 gigahertz or 5.1 for AVX based situations. So that's how easy it is. So let's try with 5.2 at 1.3 volts, so 1.3 Vcore. And when it comes to the load line calibration or Vcore VDroop option, the best value is actually minus 25. Minus 25 is a touch over the set value under load. So if 1.3 is set, the measured value will be like 1.304. So very spot on with the set value. A good option is also the minus 50%, but that will overshoot you a little bit. So 1.3 set will be like 1.32 something under load, like 1.325. So there will be a slight overshoot under load. So I recommend you use 125. Vcore PWM frequency, use like 500 or 800. Don't go over 800. So 800 is generally good. VCCSA and VCCIO depends on how high memories you want to run, but generally 1.25 is good on both of these for daily use. PCH, leave it at auto or set it close to the default value of 1.06 or 1.07. Here I have it set at 1.1. So these are the CPU and cache settings, so relatively easy. And then memory, this profile which I have included in my profile, I mean it's good for frequencies of like 4133 up to 4300. So in this example I will set a frequency of 4200 megahertz with 1.43 volts, and timings will be 17, 18, 28, cache write latency of 14, command rate is 2 because it's A2 PCB, and most of the subtimings will be actually manually set. So this is better than this is better than XMP, for example. So XMP only sets the frequency and the main timings. So all of the subtimings will be left at auto, so they will be really loose, and they do have a lot of impact on overall performance. So that's why it's very handy to set at least some subtimings manually. So these are the settings. Now I will just select boot mode, select to legacy, because we will be running Windows Server 2012 for this testing. So if you use Windows 10, if it's installed from a USB stick, then you have to leave this at UEFI. For legacy, if you have some older operating system. So these are the settings. So let's get to the OS and let's see how they run. So F10, save and exit. Okay, now we are in the operating system. So if we open CPU Z, we can see that we have an Intel Core i7 86K at 5.2 gigahertz and 4.8 on the cache. Memory 4200 megahertz, 17, 18, 18, 28, command rate 2, and EVGA Z390 DARK, BIOS from April of 2019. So very easy. On this, the CPU voltage measurement isn't working, so you have to use something else to measure the voltage if you want to. So you can use, for example, the Elite Basic. I will link this one down in the description below. So you can use this one to monitor the voltage. So it's measuring 1.302. So spot on what we set. And you can use this to overclock in the operating system as well. So let's leave this open. And I really like core temp to measure the temperatures. So the idle temps are really good because I have the CPU delidded. So like 27 to 28 degrees. So let's try Cinebench R15. You can use the newer like Cinebench R20 as well, but that does use some AVX instruction set, so it will be harder to run than the R11.5 or the R15. So let's try to run. So we can see temperatures are staying under 60, like 59 max at the moment. Maybe it will hit 60, and voltage is spot on what we set because I'm using the -25. If it was -50% small VDroop, it would be like 1.32. So that's why I really like the -25 option. Score was 1725 points, and max temperature was only 59 Celsius. So that's very good temperature result. That's why it's very handy to delid your CPU if you know that the CPU is good. I don't delid very bad CPUs because it's not like there's no point. It's just easier to sell someday if you want to change your parts around. I only delid CPUs that are really good. But of course that will be your own choice. You can delid your CPU no matter how good it is if you want to. So now we got 5.2 stable. So we could just go to the overclocking section here in Elite and select CPU up to 5.3 and apply. And now it's reading current speed 5.3. Same in core temp as well. So we can close this and open CPU Z to validate that frequency. So yes, it's reading at 5.3. But will it be stable? That's the question mark. So run. And boom, it's unstable. So that's how fast it already went. So now we know that it's not stable. So we have to increase the voltage if we want to run 5.3 stable. So now I will just reboot the system. Okay, so that's a past result at 5.3 GHz with 1.35 set Vcore. Same load line calibration option, so around 1.35 under load. So 5.3 core, 4.8 cache, same MEMS, so everything same. So before deleting, this CPU was maxing out at around like 5.2 GHz, 5.2 at 1.34 volts. And this was already, this was almost passing at 1.34 volts. I think it will pass with just a good run. I first tried at 1.32 volts, but it always crashed at around like 50%. So that shows us that deleting gave us like a bit over 100 megahertz on this CPU. Max temp was 61. Before deleting was like between 75 and 80, like 77. So quite good temperature scaling. So over 100 megahertz more when CPU temperature dropped like 15 degrees or so. So quite good scaling. So that already shows us how important the actual CPU temperature is. So it's not only about the voltage, but it tells now that as 5.3 needs already this high voltage, it tells us that it's very likely that we cannot pass 5.4 at all in Cinebench, no matter if we set Vcore over 1.4 volts. So this will be our max frequency for all cores and threads on water cooling. So a very good CPU should do at least 5.4 under 1.4 volts. Because if you remember my 8700K video on Z170M OC formula, it did 5.4 in R15 with 1.3 set volts. Real measured value would be like 1.3x, like 1.3 something. So this is behind. But this is, well, this is not like a bad result, but it's not like top notch either. So now, as we passed 5.3 in R15, we could start looking for like 5.2 daily stability in Prime 95. So we could, like, let's close the R15, and we could start looking for, oops, that's wrong Elite, because this is a recycled operating system from X299. So I generally like to use this basic Elite on Z390. So let's drop the CPU frequency down to 5.2, and let's put, and we want to disable all AVX, so small FFTs, maximum power, and so on. Actually, it's funny, so it's not that much warmer than R15, at least during the few seconds or so. But of course it will ramp up at least a bit once we let the test run, but you get the idea anyways. So I'm fully sure it will be stable at this frequency, even if we now let this run for like 2 to 3 hours. If it's stable even after that time, it will be stable pretty much. So, but this is the way you want to test. So you can use Cinebench R15 for pre-testing, and once you get the feeling like what is stable, where the limits are, then you can come back down like slightly. We could even try 5.3 in Prime 95. We could increase the Vcore to like 1.38 or 1.37 or 1.38, then run the same test, so 2 to 3 hours in this Prime 95 with max heat at 5.3, because our cooling solution is already so amazing. look at these temperatures really. 60, 61, 60, 62, 57, 60. So it's far from the high levels pretty much. And my room temperature at the moment is 26 degrees, so it's not the coolest possible. So if this is stable after 2 to 3 hours, then you can try 5.3 or the next step with a bit higher voltage if you want to, and then we could just use AVX negative offset of like 2. So we would have 5 gigahertz overclock for all AVX based workloads. We could do a quick attempt just out of interest. So let's stop this. Stop. And to show the temperature difference, I just want to show you. So torture test, small FFT, but let's not disable AVX. Just look at the max temperatures. So small FFTs with AVX. So already hardest core around 70 broken. But look, it dropped the frequency down to 5 gigahertz because of the AVX negative offset of 2. So you can do another test, like you can test your negative offset. So is 2 enough, or do you need value of 3? So then if you use value of 3, it would drop it down to 49. But as you can see, 5 gigahertz with AVX is warmer than 5.2 without AVX. Of course the voltage is same, but the frequency itself does impact temperatures as well. So it's not only about the voltage, but you get the idea anyway. So that's how it works. So that's how you have to test your CPU stability. A few hours in Prime 95 is enough. Once you move on to memory, the best way to test memory stability. So for example, if I wanted to retest this configuration once again, I have tested this many times already. So 4200, 17, 18, 18, 28, command rate 2 with most of the subtimings tuned manually. Let's open Task Manager so that we can see the total memory. Is that we use the Hdi Mem Test. There are newer programs out there as well, so you don't have to use this one. But this is the one I have been using. So open as many executions of Hdi Mem Test as needed to test actually we have to do, what's this? Yeah, it's because I'm not using the paid version, but you can just open many executions of Hdi Mem Test like this and let them all run up to 100% to complete without errors. If the entire capacity has been tested 100% without any errors, that's pretty much fully stable. So you have to open quite many. So now we have 5 open. So this is the number 6. And now we only have 12.3 gigabytes tested out of 16 gigs. So we still need like... So now we have 14.2. So let's put 1500 so that we don't run out of memory. So yeah, now we are on the limit. So we cannot... So now we have 15.7 gigs out of 15.9 being stressed, so 99%. We would have to let this run up to 100% on all of the executable windows. And if there's no errors, if every window goes up to 100%, that's pretty much fully stable. This does stress CPU a tiny bit, but it's not that bad. So like 40s. Mid 40s on the CPU temperatures, so not that bad at all. So just let this run. If every window gets up to 100%, you know you have stable memory configuration. That's how easy it is to overclock and test your 8700K or 86K and the memories you use with the CPU as well. So that's how you do it. So if you have any comments or questions about overclocking any of these CPUs on the EVGA Z390 DARK, then please drop them down below. And other than that, like this video if you like this, and thanks for watching, and I'll see you on the next one.